Assalamualaikum and good morning. My name is Wafa Widat binti Abdul. I'm from the RP4A. Today, I would like to present about my presentation is clock. Okay, for the content, we have introduction, objective, part to be studied, generation attribute, old design and new design, process that will be eliminated, final process and suitable material. So, what is DFM? DFM is design for manufacturing. It's the process of creating goods, parts or components that are simple to manufacture with the aim of producing them with affordably. This is accomplished by streamlining, improving, and perfecting the product design. Sometimes DFM and the abbreviation DFMA are used interchangeably. So, this is the objective. First, to optimize permanent components with the goal of reducing overall manufacturing costs. Second, to compare the final process for original and redesigned parts. Then, third, to minimize the overall component count. Fourth, identify the suitable process and material. And the last one is choose a manufacturing method that is appropriate for the chosen component. Okay, so this is the part to be studied. Okay, in this section, it shows the part that is selected to be studied and discussed upon to decide the processes and the material that is to be used to produce. Below is represented part that has been selected. So, function, it covers the clock face from being exposed and shows the time. Strength and weakness, time is easier to visualize. An analog clock, they might be inaccurate. New design, so we redesign with the same size by adding slot to merge the clock face and clock cover. Make the analog clock quieter. Is generation attribute for original part, so its function and strength or weakness also same with part to be studied. So function, it covers the clock face from being exposed and shows the time. And strength or weakness, time is easier to visualize on an analog clock and they might be inaccurate. So this is original design, manual handling and also manual insertion. For manual handling, one hand, parts are easy to grasp and manipulate. Code 13 and the time is 1.95 seconds. And manual insertion, part secure immediately. No screwy operation or plastic deformation. Easy to align and position. No resistance to insertion. Parts are associated tool can easily reach the desired location and the tool can be operated easily. And the code is 30 and the time 2 seconds. Okay, so this is the meaning of shape attribute. First is depression, the ability of manufacturing process to form recess or groove in the surface of the part. This attribute has two columns. The first one is the possibility to form depression in single direction, and the second is refer to the possibility of form depression in more than one direction. And the second is uniform wall thickness, shows if a certain manufacturing process can produce a part with uniform wall thickness. And the third is uniform cross section, the ability of the process to produce a part where any cross sections normal to the part axes are identical. 4. Axis of rotation. The process can produce parts which are solid of revolution. 5. Captured cavities. The process can form cavities with re-entrance surface in the part, for instance, a bottle. Regular cross-section. The process can produce parts whose cross-sections normal to the part's axis contained in a regular pattern. Change in shape that maintain a regular pattern are permissible. 7. Enclosed. The process can produce parts that are hollow and complete enclosed. 8. Draft-free surface. The process can produce parts which have constant cross-section in the direction of tooling motion. This attribute can be fulfilled by many processes, but this design is reserved for a process where this capability is a basic characteristic and no draft can be obtained without cost penalty. Example of process that fulfill this are extrusion and machining. Solution for this part, using the procedures of eliminating the process and material in terms of shape producing capabilities list. This part is specified as follows. Depression, yes. Uniform wall, yes. Uniform cross-section, yes. Axis of rotation, no. Regular cross-section, no. Captured cavity, no. Enclosed cavity, yes. And no draft is no. Okay, this is the final process. The table above shows how solve the problems on the clock. It covers clock face from being exposed and shows the time. Then make the analog clock quieter, and also has been changed to simplify the design so that it does not have many parts. Moreover, I studied how to assemble it more details so that the method is easier. Conclusion, the diagram above shows the after performing the eliminate process on the original part, and there are several finishing process for original parts that can be used to get the shapes. After doing the eliminate process on the original part, the last remaining process that can be used is the first part, deformation process, which is by using hot extrusion and injection molding. In addition, the machining process for the material removal process, we remove part of blow molding, rotational molding, rotary swagging sheet metal, thermoforming, metal spinning, wire EDM, ECM, EDM, machining closed die forging, cold heating, impact extrusion, and structure form molding. So for the suitable material, for this new part, the suitable material chosen to produce this part is thermoplastic. In addition, the material of the object also plays a role in the object, so that it does not put pressure on the object. Thermoplastic are ductile and impact resistant. In many applications, thermoplastic have a longer service life compared to alternative material because don't then ding, chip, crack, splinter or fray. Then thermoplastic have a low melting point. They are ideal for applications that are used recycled materials. Thermoset plastic, in contrast, are able to withstand high temperatures without losing their shape, making them more durable. Thank you.